Hello everyone, myself Hans. Today we are going to solve the given problem of UPC 2016 from paper 1. Here in the question, solve dy by dx is equal to 1 upon 1 plus of x square in the bracket e to the power of 10 inverse x minus of y. Let's solve the problem. Given differential equation is this is given by dy by dx is equal to 1 upon 1 plus of x square into bracket e to the power of 10 inverse of x minus of y. Given differential equation, given differential equation, given differential equation can be also written as 1 plus of x square cross multiplication with dy by dx. This gives 1 plus of x square dy by dx is equal to e to the power of 10 inverse of x minus of y, and from here minus of y is taken to left hand side. This gives 1 plus of x square into dy by dx plus of y is equal to e to the power of 10 inverse x, and we can also 1 plus x square divided by both the sides. This gives dy by dx plus 1 upon of 1 plus x square into y is equal to e to the power of 10 inverse x upon 1 plus of x square. This is the form of linear differential equation. Comparing the above equation with the linear differential equation, this is dy by dx plus of py is equal to q, and from here that is this is p is equal to 1 upon plus of x square and q is equal to e to the power of 10 inverse of x upon 1 plus of x square. We have to solve the linear differential equation using first we have to find integrating factor, and integrating factor is given by e to the power of integral p dx, and from here this is e to the power of integration p. Here p is 1 upon 1 plus of x square, 1 upon 1 plus of x square into dx, and we know that dx upon 1 plus of x square, this gives 10 inverse of x. This is e to the power of 10 inverse of x. This is the integrating factor, and we have to find the complete solution by y into integrating factor is equal to integral of q into integrating factor into dx plus of c. We have to put the value here. This gives y, and the integrating factor is given by, we have to calculate earlier, this is e to the power of 10 inverse x and is equal to integral of, here q is e to the power of 10 inverse of x upon 1 plus of x square, and integrating factor is into e to the power of 10 inverse of x. This is dx plus of c, and from here we can also write this is y into e to the power of 10 inverse of x is equal to integral of, here if the base are same then powers are add, then e to the power of 10 inverse x into e to the power of 10 inverse x is written as e to the power of 2 10 inverse of x upon 1 plus of x square, and this is dx plus c, and further we have to let 10 inverse of x is equal to t. This gives 10 inverse, this is once again tan inverse, this gives 1 upon 1 plus of x square dx is equal to dt, and we have to remove from here dx. This gives dx is equal to 1 plus of x square into dt, and put the value here. This gives y into e to the power of tan inverse of x is equal to integral. Here we have to let tan inverse x is t, so here is e to the power of 2t upon 1 plus of x square, and in place of dx we have to put here into 1 plus of x square into dt, and here is already c constant. 1 plus of x square to 1 plus of x square is cancelled out, and the remaining is here. Once again we have to write here, remaining is here. This is y into e to the power of tan inverse of x is equal to integral e to the power 2t into dt plus of c. We have to integrate here. This gives y into e to the power of tan inverse x is equal to, we have to integrate it, e to the power 2t dt. This gives e to the power 2t, and again 2t differentiated with respect to t, and this gives 2 divided by 2. This is 2 plus of c, and further we have to put the value of t here. We have to earlier let tan inverse x is t, so y into e to the power of tan inverse x is equal to e to the power of 2. In place of t we have to put here tan inverse of x, and here is upon 2 plus of c, and from here we can also e to the power of tan inverse x is taken to denominator of this function. This is y is equal to e to the power of 2 into tan inverse x upon 2, and e to the power of tan inverse x is taken to denominator, and plus of c upon e to the power of tan inverse x. And further we have to solve. We can also write here, this is y is equal to, we can taking 1 by 2 is constant here, and e to the power of tan inverse x is taken to denominator. E to the power tan inverse x is taken into numerator, sorry. This gives e to the power minus of tan inverse x and e to the power of 2 tan inverse x. This is e to the power, once again we have to explain here. This is e to the power of 2 tan inverse x, and when we take e to the power tan inverse x into numerator, this gives e to the power of minus tan inverse x, and here is multiplication sign. So we have to, if the base are same, the power are add, so this gives e to the power of 2 tan inverse x minus of tan inverse x. This gives tan inverse of x. So we have to write here 1 by 2 e to the power of tan inverse x plus of c, and 1 upon e to the power tan inverse x is taken to numerator. This gives e to the power of minus tan inverse x, and this is the required solution of the given problem. UPSC asked it 2016 for 10 marks. Thank you class, and thank you for watching.